We talked about product and sum rules, and they are based on elementary observations. And this inclusion-exclusion principle is also based on the observation regarding the cardinality of set union in terms of the cardinality of the individual sets and their um, intersection. Essentially, the reason for this is that, let's say you have two sets here, A and B. Obviously, if the intersection is empty, the cardinality of the union would be equal to the sum of the cardinalities of these two sets. However, if the intersection is not empty, if you add the cardinalities of these two sets, essentially you are counting the elements here in the intersection twice. So to compensate for that, you subtract the intersection here. So this is essentially what we call the inclusion-exclusion principle. You exclude the multiple inclusions you did earlier. So this is the two set case. Of course, if you have more than two, let's say you have another one, C here. Now what happens here is when you add the cardinalities of A, B, and C, now these are okay, these are counted once, and the intersections here are counted twice. So to account for that, you subtract them. Subtract the intersections. But now, the elements in this part have been subtracted excessively because I have subtracted them, well, I have added them 3 times, and then I have subtracted them again 3 times. So at this point, they are not accounted for. So I have to add them once, all the intersection here. And again, this can be generalized to multiple sets, let's say n sets. If you have sets A1 through AN, the cardinality of the union is going to be equal to the sum of the cardinalities of each individual set minus the cardinalities of intersections 2 by 2 plus the intersection of triplets minus the intersection of quadruplets, etc., depending on the number of the number of sets n. This multiplier here is determined either -1 or +1, and finally you get the set of the intersection of all of them. So let me give you a quick and simple example. How many integers in the set from 1 to 100 of integers are divisible by 2, 3, or 5? So either 2 or 3 or 5. So for instance, 2 counts here, 3 counts, 5 counts, 4 also counts, 6 counts, and 8 also counts, 9 counts, and 10 counts, etc. You get the idea. 2 or 3 or 5. How are we going to do that? Let's define A2 as the set of elements in set A that are divisible by 2. Similarly, define A3 as the set of elements in A that are divisible by 3, and set A5 as the set of elements in A that are divisible by 5. Now, to obtain the number of elements that are divisible by 2 or 3 or 5, that is essentially the union of these 3 sets, because this is 2, 4, 6, 8, 10, and ... and this one is 3, 6, 9, 12, 15, ... and finally this one is 5, 10, 15, 20, 25, ... up to 100. okay? And the union will be, well, 2, 3, 4, 5, 6, 8, 9, 10, dot, 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 etc. How am I going to find the cardinality of the union? Apply inclusion-exclusion principle. First of all, add the cardinalities of these three sets and then subtract the intersections of pairs and then add the intersection of all three. And this I can find using this expression. 100 divided by 2, take the floor, gives you the cardinality of A2. 100 divided by 3, take the floor, gives you the cardinality of A3. 100 divided by 5, take the floor, gives you the cardinality of A5. For the intersections, you have to multiply them because you are looking for the numbers in both sets, which means the intersection of A2 and A3, for instance, consists of numbers that are divisible by both 2 and 3, which means they will be divisible by 2 times 3 is 6, and so on. And this intersection will be the numbers that are divisible by 2 times 3 times 5, which is 30. So here, in fact, it will have just 3 elements, 30, 60, and 90. But you see, take 30 for instance. I have added 30 in this set, and also this set, and also this set. So in the first, at the beginning, it was added 3 times. That is excessive. So I'm subtracting these intersections. But now look at 30. 30 is in here, so subtract it once. Also here, subtract it twice, and it's also here. Now subtract it 3 times, which means it hasn't been added yet. So to compensate for that, I'm adding this one. Same as 60, same as 90. But for instance, take, let's say, 20. 20 is divisible by 2, it's divisible by 5, but it is not divisible by 3. 20 is thus added in this set, not in this set, but in this set, and then it's not in this set because 3 doesn't divide 20. It is in this set, so it's subtracted once, okay? It's not in this set, doesn't appear in A3, and it's also not in this set. So you have added it once, added it twice, subtracted once, so it has been counted just once.